I've got a really short PowerPoint here. As you can see over here at the left, I've only got 5 slides, and this is really just to keep me on track and give you an overview of what we're going to cover today. Okay, so we'll really do a cross section of all of those products that Chad had mentioned, specifically SolidWorks. I tried to put this wheel that you saw in a previous slide in here to give you a good reference about where we're going. So this SolidWorks piece, I have a lot of really nice examples here of an inhaler just to show kind of the user experience, testing movement, those kinds of things. Then one with joints. So you can see down here in the bottom left, I've got this knee joint ready to go. This can show us how SolidWorks can go into reverse engineering of bones, and then using those to create models, how powerful the system is and some of its surfacing capabilities. And even some simple things that you might not think of that really apply to the medical industry is being able to apply material and get mass from that so we can get an accurate weight of what our products are going to weigh. Then lastly, I'll show a wheelchair, and this one will be for automation. So if you have a product that's highly configurable, it's basically the same product except maybe you interchange some parts, maybe you have a different number and a pattern. This allows you to fill out a form and hit print, and it'll go ahead and make all the CAD models and drawings for you. So that'll be nice. Then we'll hop over to 3D via Composer. We'll talk a little bit more about documentation, this section up here on our wheel, mainly for either work instructions, how to put something together or take it apart. You can think of that for your manufacturing floor or for your end user. And we'll use this MediJect example that you see over here in the bottom right. Then we'll hop over to simulation, which you see in the top right here. We'll talk about lots of different ways that you can apply the simulation tools to medical industry. The first example I'll show you is with that same MediJector, and we'll test a snap. And you can think of this as like a living hinge as well. So as many times as we snap this lever back and forth, what's that going to do in the stress environment on that plastic piece? We'll bring up this really neat oxy-arm example, which helps to feed a certain level of oxygen to a patient, and that way we'll get to touch on the air fluid flow tools that we have. And then lastly, in simulation, I'll bring up the peristaltic pump, and that way we can see the motion tools that SolidWorks has, and we can evaluate forces in a system. A lot of times this tool is used to see how much torque or how much force that we need from a motor to drive a certain system. So that's a really neat model. And then lastly, we'll talk about EPDM, this piece in the middle. All of these different tools are creating multitudes of files. How we handle those and how we keep track of those is with EPDM. That's Enterprise Product Data Management. And I'll use that inhaler again and just show you some examples on how you can use that to fit for regulatory compliance, archive your product info, and standardize your processes of approval and changes with EPDM workflows. Okay? First, we'll start off with SolidWorks. It's just really what I'm going to bring up here is just a bunch of different models to show you how easy it is to move around, how to show someone something. It sounds simple, but usually it's really important to be able to, you have your engineers designing, but you also want to be able to communicate those designs to upper management, to your end customers, to manufacturing floor, and then it also has to be a powerful tool. So we'll walk through those. Again, I don't see any questions coming in the chat. Feel free to chat any questions that you have, and Chad and I will do our best to try to answer those. So first up here is this inhaler model, okay? And I just want to show you what it would be like to use SolidWorks. If I hold my right mouse button down and just wiggle a bit, we get these mouse gestures. Some of these things might seem small, like small features, but when you add them all up, it really adds up to a nice user experience and be able to quickly get to where you want to get to. So all of these mouse gestures are set up to get me to certain views. So if I swipe up, it's going to take me to a top view, and I can change these if I want to as well. But it's really nice to have all these views here available for me. Another way to get around to different views is if I hold control and hit the space bar, We can customize that too. SOLIDWORKS is really customizable. Brings up this view cube, as I like to call it, and we can pick on any portion of this view cube to take me to that view. So if I want to go to kind of an upper right view here, I can click on that little spot right there, and it'll take me directly to that view. You can create your own views as well. So if I know that the hinge on the bottom of this model is going to be really important, and maybe I want to use this in a drawing later on, I can just hit that space bar, and I'm going to hit New View and add a view name to that. I'll just call it Greg's View here. Now, anytime I'm moving around, I'm going to standard views, I want to get back to that previously set up view I've got, I just hit that space bar and click on that view that I've saved. So some really easy ways to manipulate and move around your model. Okay. Also, in that same thread is being able to hide and show components. So it's really easy. You just click on a component, and there's this looks like a little part icon with some glasses on it. If I click that, it will hide that component. That way, I can easily see the inside of it. You say, how do I get it back? And instead of looking through the tree to find this, I can actually just right-click out in space and choose Show All the Hidden Components. Now I can click on the components that I want to unhide, hop back to the regular viewing environment, and it's back. Same thing with transparency. I can click on this part, and instead of choosing to hide it, I can actually make it transparent. Okay, different reasons you might want to do this. You want to see the part with the rest of the assembly, but you also want to see inside of it. A bunch of different reasons to use that. We'll go ahead and make that opaque again. You can really quickly section this model to view the inside of it. Okay, so I can, right on this heads-up display, you'll notice that I'm getting feedback for each button that I hover over. Tells me what it is, gives me a short description, and I can just click on that, and it's going to go ahead and section my model. We can section it by any plane in the model. They give us some nice quick buttons for these standard planes like front, top, and the right plane. And with any of those, this is a dynamic section, meaning that I can grab this arrow that's attached to the plane and drag it through the model. Just a lot of different ways to be able to show, kind of interrogate your model a little bit to see what's actually going on in the inside of it. Okay. Beyond that, actually, just viewing it, we can actually analyze it for, let's say, interferences or collisions. Okay, so first one, we'll do some interference detection here. I can go to this Evaluate tab, go right to Interference Detection, and I want to see if there's any interference between what's called the cap of it and the body portion of this. And I'll hit Calculate, and it'll say no interferences detected. I don't know if you heard that or not, if it's coming over, but I actually changed my sound to if I get any interferences, I get the Homer Simpson don't. So something fun there. That's interference detection is if something's in a static state, if it's not moving. We've also got collision detection, which I'll play with the cap here and move it out and in and see if we have any interferences when we move this hinge joint here. So if I click and drag it now, it says the component's fully defined. It's stuck there in place. I can find the mate, which is what we call how we put these parts together. I can find the mate that controls that really easily. Just right-click on that component, and I'll choose View Mates here. So hopefully you can see that little paper clip with the glasses. And that way it'll show all the components that are mated to that component, and a little dialog pops up to show me each one of the mates. And if I hover over those, you can see what components are mated together. And what I want to do is if I want to test this motion, I'm going to go ahead and suppress this angle mate that's locking it from being movable. Now, since I turned that off, I can move that around. Let's go ahead and turn on collision detection. And I can grab this component and yank it out. Up, so it started in a colliding position. So we've got an issue there. Something we can come back and take a look at. I want to show that to you. And you can see it highlights the faces. If we look down in here, that's where we're getting a bump using its collision detection. So SOLIDWORKS tools are really powerful. Hopefully you get a decent look into how you can how you can hide and show components, get transparency, test movement. And if you add all of those things together, I'll show you an animation that's been created here. We can kind of combine all of those and create an animation here by just dropping keys. Maybe move a component, move my timeline, and move it again. And I'll show you the animation that I've saved off here. See, we're sectioning through the model, zooming out at the same time, showing the motion of the cap, even the motion of the spring, pressing it in. A nice little red model was put in there to show the actual spray. Okay, so that's the first model I had to show you. Next one we'll open up is the leg assembly that I have, and I really like this one. I've used this one quite a few times to show different functionality. Okay, and really all this is an assembly of a couple of bones in a knee joint that's been created for them, and also a stem. I've made this completely movable here. You can move that back and forth. And you might ask, how can we get these bones in here? Well, with SOLIDWORKS Premium, you have the ability to, we'll go ahead and open that up in its own window. You have the ability to scan in, and SOLIDWORKS can read that scan with Scan to 3D, which is in SOLIDWORKS Premium. From here, we scanned in the bone, made a solid model out of it, and then even went a little further and created the cuts that need to happen in the bone for the certain product that we're going to put into it. So if I roll up the tree here, this feature tree, we can see the very beginning as it was imported. That's a scan of a regular bone right into SOLIDWORKS, and then we can add features on top of that. So we created a nice cut on the top of it, and then a couple of indentation tools to indent where that stem needs to go. If you think about it, you can even use this bone, create a 2D drawing of it to show a doctor or a surgeon what cuts need to be made in the bone. Okay. Then from here, we're going to go ahead and put the knee, the disc, and the stem here into its own subassembly. You can see it's just as easy as dragging components and dropping them into their own window. Well, why would I want to put these components into a subassembly? Is because if I can open that up in its own window, all of these parts have material associated with them. A density, an elastic modulus, a Poisson's ratio, things where we can get things like weight and do simulation with, so analyze stresses or vibration. So in this case, we'll do something simple, and we'll just go to Evaluate. We'll go to Mass Properties, and you can see the mass of this little assembly here is about 313 grams. So this is a really nice tool to be able to, if we have a weight goal, we want to match it so it feels as natural as possible, we can meet that weight goal. We'll go ahead and open up that knee in its own window so I can show you where we apply that material. It's right here at the top of the history tree. I'm just going to right click and choose Edit Material. And all of these materials that you see come with every single seat of SOLIDWORKS, preloaded with all of their material properties. We use that mass density there to get our mass of the entire subassembly. And you can even create your own. If you have special material that you order or make, you can get one that's pretty close and just change the values and have a new material for you. I think I've got one in here for nitinol or nitinol, depending on who you're talking to. That I've made myself there. Then it comes to the actual, how powerful is it? A lot of our competitors like to say, SolidWorks is a nice tool, but it's not very powerful. I've not seen a model yet that I couldn't model inside of SolidWorks. I'm pretty heavy on that side of doing some complex modeling. So let's take a look at the very first feature that makes up this knee here. Let's do the second one. Okay, you can see here that we've got a couple of 2D sketches at the end. So this M shape right at the top, and then we're just using the edge of the model, of the rest of the model, the surface from before, and we're lofting between those. We can even build in guide curves, we can build in tangency or even curvature to the face. So it's a very powerful tool. All right, we'll move on to our third SolidWorks example here. And this is using DriveWorks Express. DriveWorks Express comes with every seat of SolidWorks, and it's that automation tool that I had spoken of. I just go to Tools, DriveWorks Express, and it'll load up there. And you can see that my form will just pop up here on the right. I want to run some models from a certain database, and I'll hit Next. And then this is the form that we can create and then fill out. I'll go ahead and we'll type in a project number for Greg Dawes here is creating it, 0002. We can pick, have different things be configurable, like the color of the frame. We'll call that metallic. Maybe we want 7 spokes on our wheels instead of 4. What types do we want? We have different frame styles, whether it being a standard, sport, or domestic use. So we'll call it standard here. And then we can customize the frame even further by inputting lengths for shin and thigh. So we'll put in 400 and 425. You can see as I hover over each one of those fields as well, it'll tell me what it will accept. So if I hover over that field, it says select a value for thigh length between certain values at a range of 25. Okay. What material do we want the frame to be made out of? We'll call that titanium. And the creator will be Greg. And we don't want any handles on this one. So it's just a very configurable assembly that we can fill out a form, and when we hit create here, you'll see SolidWorks work through creating each one of those assemblies. Created the caster wheel, frame for it. It's added foot pedals because of the larger size that I put in for the shin and thigh length. Even creating the drawings for it as well. All by just walking through that form. And then at the end here, it's going to show us the final model. So we can see 7 spokes there instead of the 4. Creating a drawing of that wheel. And lastly, should put together our assembly for us. And there we go. So you can see if you have a well-defined process of a configured model, we can put that all together into a form and have SolidWorks create the model for you. All right, let's talk about some of the other products that Fisher Unitech sells along with SolidWorks is 3D Via Composer, and this is the document software that we talked about. And this is kind of a before this company had adopted 3D Via Composer, and it's a similar process for what people do. They make a prototype, or they make the end model, and then they take pictures of it, and put it into, let's say, a PDF or a Word document or Microsoft Publisher. So you can see that this is probably a real model here, and as we go through the pages, you can see that they're using a real model. The images are okay. They've broken it apart a little bit. But if any change needs to happen to the engineering model before it's released, then we have to scratch this and start all over, take our pictures again, and do all of this work again. You can see they've used either Illustrator or Photoshop, some tool like that, to add these arrows. Very compelling images here. Okay, so how would we do this inside of 3D via Composer? I'll go ahead and bring up that same model. What we're doing here is just taking the CAD model and bringing it into 3D via Composer. And we're not breaking any of the models. We can't change dimensions inside of Composer, so it's really built for someone who creates this documentation. And it's really easy to, let's look around some of these different views, is to create really nice, compelling images from the actual CAD model. So let's take a look. I really like to be able to show the bill of materials as well. If we move that around, you can see how we can explode the part. So let's make our own view here and walk you through what it takes. We'll go to this cover image. And I'm just going to snap off a new view from that image. And you can see I get a new view over here in my views palette. I'm going to rename it. Something that is recognizable and I can get back to. And I've got the full 3D model I can play with here. I can rotate it around. We'll rotate it to about there. Looks good. I'm going to go ahead and add in an arrow here. We can render this in different ways as well. So if I don't want to see those edges, I can change that to smooth. Or if I know I'm going to print this in only a black and white format, I can choose a silhouette style and just get a line art version of it. I can turn on flat technical. If we want something, if we know we're going to do kind of a medium print process with this, we'll go ahead and change it back to smooth with outline. It looks pretty good there. And I'm going to author an arrow, a circular arrow here. And you can see as I move over the model, it's snapping to different cylinders. It's really nice to be able to have that a model in there for arrows to snap to. We're not really guessing how we're going to put that arrow on there. So I'm going to go ahead and click once to apply that on there, and then click again to show where I want that to be. We can change different aspects of this arrow, like I like to make it flat. Okay, so we can actually see it rolling around in the model. We can change its radius as well. So we'll grab that arrow. Okay, and we can change different properties of it, like the radius of it. We'll bump that up a bit. Change how far it goes around, maybe even the head shape a little bit. I like a little bit more of a classic arrow here. And we want the angle to be changed as well. Looks good there. We'll make it completely opaque. Right now it's a little transparent. You can see it's really easy to add those. We're going to add a couple of labels as well. And we're going to say, by default, it's actually grabbing the SOLIDWORKS name of the part. So you can tell that metadata, whether it be description information, properties such as cost, anything that you added to your SOLIDWORKS model can be used in 3D via Composer. In this case, we're going to change it here. We'll say turn 1/8. And there we go. So you guys can get a pretty good idea of what it takes to create all these different views. We'll just update that view. Then, where it really becomes handy is if this model changes. Maybe the cap completely changes to a different shape. We don't have to start this process all over. We can just go to File, Update, and update this Composer document with the latest and greatest assembly that we have. We don't have to remake these arrows or the positions of the parts, the flags like that turn 1/8. We don't have to redo any of that. It just updates the parts with the newest parts. And then show you kind of a final here, something you might create with Composer. We want the final assembly here. Kind of redid their current one with Composer images. You can see we're getting that image from Composer. Copied one of the views that they had and turning it around, adding some flags, and then went above and beyond a little bit from what they were able to do and add a replacement parts page that shows in a kind of a silhouette view all of the different parts. Add a bill of materials inside of Composer as well, and even show an exploded view with some nice lines to show how it goes together. Okay, and that is what I had to show you for Composer. Okay, so it just provides graphical content for technical documentation. We talked about most of that. Next, we'll hit Simulate, SOLIDWORKS simulation tools. Okay, you can test and validate your model. I've got a little video here, and I'll walk you through how easy it was to set up that snap that you see. You can see that meta ejector. We had a push pin, and it snaps over a contour on that plastic piece. We'll walk through that. I've also got that oxy arm that I talked about, where it delivers a certain amount of oxygen to a patient. We'll walk through that and see, go through flow, see how we can see the different simulation results. We can view them in a multitude of ways. Okay, and then I've got that motion study with the pump. All right. And we'll grab this is the meta ejector with just a bunch of the components hidden. They're still in there for the simulation. They're just hidden so we can easily view the key aspect of it. And that's just as easy as setting up a display state. So we've got display state 1 with everything in there, including this teal snap. And I've set up a display state that only shows the lock. And there we go. What we've done here is set up, see if I've got the refined one calculated through. There we go. And I'll walk through, let's show that. You can see these little green icons there on those two faces. Okay, let's go ahead and edit that fixture and show you how this study was set up. All I did was say take these two faces on this side and this side, and move them normal to this pink plane, which means just in this direction here. If you can see the axis down here at the bottom left, it's in the X direction. Move that 3.74 millimeters, and that's all. Then I just run the study. Okay? And let's view the results here. I can get a multitude of different results. We'll view stress here first. You can see my chart here at the right, where we go from 0 all the way to 50 megapascals here. And you can zoom in and see where we get those stress hotspots. A lot of different ways to evaluate this as well. I can right-click on that and choose an ISO clipping. So I only want to see the values that are above 8. So I can see where my stress hotspots are again. That's a really nice tool. We can section clip this as well, which is basically just like a regular section. I always like to point out that you can see the color change through the thickness of the material as well. So it's not just doing this study on surfaces, but it's doing it through the entire solid. We also have a probe functionality too, and this just allows me to graph this really easily. As we move along this space here, I'm just going to click on different areas to see how the stress changes as I move through the part. Then I can always plot that as well. Some really nice tools to be able to plot those points. And this is easily exportable to like a CSV format, which you can read in Excel. All right. Let's close that model, and we'll open up the oxyarm model. This is one of my favorites, actually. I'll load the results here. The results can be saved as a different file than the actual part, so the part opens up quickly without having to load the results right away if you don't need them. And I want to show you how this was set up. First off, the model here with the headset and the piece, the diffuser piece. And if I click on this inlet volume, this is what I've set up, is an inlet volume flow of 10 liters per minute right at that face. And then it's going to see all the rest of geometry and interact with it accordingly. So let's take a look at some of the plots that we can get from it. I'm going to go to some predetermined views that I've set up so we can see this. Cut plot. So we're going to show that cut plot. The visualizations that you can do inside of Flow are almost endless. I've got a cut plot set up, a surface plot, an ISO surface, which I think is the best for this example, and then some flow trajectories as well, so you can kind of animate how it's going to flow through here. So right now we're looking at the pressure. We can quickly change this with just a click on that word pressure here. I'm going to change it to mass fraction of oxygen. You always want that to be within a certain range here. So we'll click on that. And you can see it's well around 0.4, 0.5 through this section plot, but we may want to see it a little bit differently. So I'm going to hide the cut plot and show just the surface of the face and how in that same mass fraction of oxygen. We're going to look at this view here, and this shows us a little bit better about how it's actually interacting with the person that we put into this situation. And then we're still around 0.4, 0.5. We can actually see how wide it goes, maybe make changes to the diffuser model or how the headset is on based on some of these results. We'll hide that surface plot, and we'll show the ISO surface. And I think this one does the best. It's just like the snap I'd shown you earlier. We're only saying, hey, show me anything that's below 0.5. So it only shows me that area that it touches below 0.5. Then lastly, we can set up from the same study. We're just viewing it in different ways. I'm going to show the trajectories. So this is a nice little, can either be static, just like this. We can see, based on the color, the mass fraction of oxygen there. And we can even animate this as well. So if I right-click on it and choose animation, we can play through that animation to see how that diffuser is really working. Okay. Feel free to chat in any questions that you have. We'll move on to the peristaltic pump here. This is a pump used to just pump fluid of different kinds through it. And what we really wanted to know is what kind of torque is it going to take to, what kind of motor do we need to make this motion happen? Maybe we can also see the stress on the cam lobes throughout this assembly as well. And that is all about motion here. Okay, and I'll play through this real quick. You can see We've got that springing up and down. And that's all from adding these forces. And we've got the exhaust force, the intake force, and a piston force. If I look at the exhaust force here, we'll go ahead and edit that. You can see it's based on an expression. If I edit that expression, you can see it there. And this expression is just based on a spring. So the force of that spring is pretty well known. So we can add that in as an expression here for the exhaust, the intake, and the piston force. Okay. And then what we want to know is the torque it's going to take to go through. Let's play it about half speed here. Play through it again. We'll loop it. The force that it takes to compress this tube is well known too, so we added that to the equation as another variable. So we know the movement that we want. Now we want to know what kind of torque is it going to take to move this assembly down here to push those. So we'll stop that, and I can actually pick any component in the model and get different results from it. So let's come down here to my results, and I've previously set up a motor torque plot. And here you can see our motor torque. The highest that we're going to need is this 77 Newton millimeters. We can kind of scroll along there. What's really nice is I can compress this, behaves really well, and I can drag and click on different parts of the graph, and it will take me to those time points on my actual assembly here. So I want to go, okay, at what position do I need the most amount of force? And I can view that here, see if I can change a cam lobe geometry. Okay. We'll pick on different areas. All right. Adam had a good question here. Will a recording of this webinar be available to view later? Yes, it will. I think I am recording it right now. So, Adam, I'll try to get your contact information later. I think we'll have it because you registered for the event, and then we can send that link out to you. All right. Let's go ahead and close this model. And then that last piece of the puzzle is EPDM. Okay. You've seen all of these different examples on how we can create the geometry for the models, how we can create documentation to show how to put it together, take it apart, how to use it. Simulation, so we've got analysis results files that we need to keep track of. SOLIDWORKS Enterprise Product Data Management is the flagship tool for that. And allows you to securely manage all your engineering data, improve processes and communication. Really, this first slide, I think, covers it well. For the specific medical device industry, regulatory compliance can be big. FDA has a lot of requirements. Prove that you put this product through its necessary paces and tracked it all along. No changes that were made weren't documented, those kinds of things. Archival of product info. So how far back do you need to be able to go and show someone that calls in and says, hey, I need a new part for this product, but you sold it to them 5 years ago. So you need to be able to get to that quickly. And then standardized processes such as engineering changes that are required and even approval processes. So I've got a quick example for that. We'll go ahead and log into, you can see this blueberry here. I affectionately call it the blueberry. You can double click on this, and that's the first thing you'll notice that's different from Windows Explorer is the ability to log in. So I'm going to log in as a manager named Mark here and add in a password. You can see if I try to log in without it, it doesn't let me. Okay. We have notifications, and I've seen that there's a certain project that's moving from work in progress to pending approval. And since I'm a manager, the pending approval needs my attention, so we'll go ahead and click on that folder where it's at. And that's really nice that by clicking on this, it'll take me directly to that part and assembly inside of the vault. If you're experienced with data management in the past, one of the really neat things that you'll notice first is this is built right on top of Windows Explorer. It's not another application to open and learn. If you know how to browse around in Windows Explorer and find files, you're already about 70% of the way there on knowing how to use the product. A big difference is the bottom half of the screen here, which can be really nice if I'm a manager and I don't have a seat of SolidWorks. I've still got this viewer that's built right into it. So I can see a static view of this drawing, static view of the assembly, and when I click on that static view, it actually fires up the free viewer in SolidWorks called eDrawings. And from here, I can rotate the model around, take a look at it, take some measurements off of it. We'll measure from here to here, get a nice center distance, just verifying it before I pass it through. Also involves data cards, so any information such as product number, customer, this is completely customizable. This card can be tracked with this product. We can go back to previous versions really easily. If I right-click on the assembly and I go to, let's get the previous version, and you can see I've gone through a couple of versions here and even a revision. So my versions are numbered, so think of these as iterative and it's not quite approved yet. Once it gets approved, it goes here. Then I can right-click on it and choose Change State and choose Approved. I can go through Analysis Required or Changes Required. You might be asking, you know, where do we get all of these? Are these preset? There is one that is preset, but if I go into the Administration tool, I want to show you how easy it is to implement and manage and go into that vault. There's a separate login for the administrator of the vault. And I can take a look at that workflow that's being used. We start in a work in progress. Someone submits it for approval. This little gold bell here are those notifications that you saw, the little balloon in the right-hand portion of the screen that fired up. Then it goes into pending approval. That's where it's at now. And to approve it, it's actually a double challenge, which is important in some FDA requirements. And that meaning, when I right-click on it, choose Change State, and approve it, even though I'm already logged in as a manager, I have to log in my password again to have this happen. And this is optional. You don't have to have this if you don't want, but I wanted to show it because sometimes it is a FDA requirement, a double challenge for the password. And I can see that all the states for these will change from pending approval to approved. If you're being audited for a process or for some certain requirement here, we can always see the history of that file and all of the things, who's done it. So the administrator created the file, went through a work in progress, then went to Neil, the engineer, and he made his changes and submitted them to Mark. We can go all the way back through, and they're all time-stamped, so it's really easy to track when it hit revision A, when it hit revision B, and then all of the other iterative changes that were made. Okay.